Hi everyone, and welcome to our series on Introduction to Metadata using the ISO 191 series of standards. I'm Jackie Mize. I'm with NOAA's National Coastal Data Development Center. We're a division of the National Oceanographic Data Center. Again, this is a series that will happen every Tuesday. And if you have multiple people in each location, say several of you are signed in with one account, if you could email a list of participants from your location to ncddcmetadata@noaa.gov. That way we can keep up and keep track of the participants in each of the sessions. Any questions, you can email to ncddcmetadata@noaa.gov, but you also have a question pane in the software that you can ask some questions to, and we have administrators helping do questions. Kathy Martin-Knowledge is also a metadata trainer here at NCDDC, and she will be doing some of the sessions as well. So Kathy and I will be going back and forth on presenting each of these sessions in the series. All the materials will be posted online, and I'll give you that link in a minute. This is going to be the class agenda for the next couple of sessions in this series. We're going to, again, this is interactive. If you have questions, email them or use the question board in. We're going to go over Metadata 101. What is metadata? How is it used, and how does it benefit you? We're going to go over the ISO metadata standards for geospatial data, what kind of information that those standards contain and how they're organized. And we're going to go over XML basics and UML basics. That's extensible markup language and unified modeling language. ISO uses these a lot. So if you know the basics about these, it'll really help you in understanding the standards. We're also going to go over some metadata tools, some different tools that are out there. By no means is this a comprehensive list or an endorsement of any particular tool or tool sets, but just what we have found have been the most commonly used or the most beneficial. We're also going to go over writing metadata. You know, what factors do you need to think about when you go to write metadata, and some methods of metadata creation. And then we're also going to discuss validating metadata, adhering to the standards, and how you can check for that. And then we'll talk about data discovery. This workshop is designed where you can work with your own data later to learn how to write quality metadata. It's a practical session that will start you well on your way to conquering the tasks that you face to learn what metadata is and how it can help you in your job. To write quality metadata that you can share with others, to learn how to help other people to write quality metadata, and to make sure that the data that we all produce will be reliable, accurate, and long-standing. These are some of the resources that we'll be using. All of the materials will be found on our FTP site at ftp.ncddc.noaa.gov/pub/metadata/online_ISO_training. Now, this was also in the emails that you should have been emailed out for the class reminder, and I will show you this. That link takes you to here, and there's several different series that we'll be running. And since this is the Intro to ISO series, all materials will be found here in the Intro to ISO. It has the agenda, it has exercises, it has the handouts. All of the fully notated presentations that we'll be using are located here. Sample metadata, that's some examples that you can use and look at. It has all the schemas for validation, different templates, transforms if you want to take from one existing standard to another, such as the FGDC CSDGM, and translate it to ISO, and the workbooks, of course. And the new folder, that's actually going to be recorded sessions. And we're recording all of these sessions that we're doing right now live, and we're as those sessions get processed, we will be posting those in the recorded sessions folder so that if you miss a week, you can catch back up with all the materials and the recorded session, or if you need a review for a later date, they'll be found here. There's also the NOAA EDM Wiki. So anytime you see this information mark on one of the slides at the bottom, you could go to the wiki and find out more information, more examples, and a lot of community help and feedback. This is on the wiki page here at this location. But if you open up that, you may get a security certificate error like this. This is because these are self-signed certificates. But this is simple. If you get this screen, just hit proceed anyway, and then it takes you right into this wiki. So don't get alarmed if you see that it's safe to proceed. There's no security issues. It's just a self-signed certificate instead of one that's bought from a company. If you just hit proceed, it will take you to the wiki, and you can look for different search topics about metadata. But again, anywhere that you see that icon on a slide shows that that will hyperlink directly to that subject that we're talking about on that slide and address more examples and go into a little bit more detail for discussion. And again, the workbooks can be found on the FTP site or on ncddc.noaa.gov/metadata-standards. All right, so now we're going to start about Metadata 101. What is metadata and why is it important? So what is metadata? Metadata is simply data about data. It answers the who, what, where, when, why, and how. It functions for documentation. It aids in management, for discovery of your data, access, be able to access your data, and to be able to use your data. So the who. Metadata answers questions about who collected the data, who processed the data, who wrote the metadata, who do I need to contact for questions, either about how the data was processed or how do I get the data, or who owns the data. Who do I contact to order this data? How much does this data cost? And who owns this data? It answers questions such as where. Where is the data collected and where is it processed? And where are the data currently located now? Is it in archives somewhere, such as NODC or NGDC or NCDC, or is it in an institution? Does an academic institution have it somewhere? It answers when. When's the data collected, and then when was it processed? That might be important if there's a large gap in between when it was collected and processed. Metadata answers questions about what is the data about, what project is this data associated with, what are the constraints on the use of this data, what's the quality, has it been QA/QC'd, and what is the quality of this data? Is it raw or has it been processed? What are the appropriate uses? What parameters were measured and what units are those parameters measured in? That's a big one. And what format's the data in? Is it compatible with my software? What other formats is it available in? It answers how. How's the data collected and how is it processed? How can I access it? How can I order it? How much does it cost, if anything? And how was the quality assessed? And then why? Why was this collected? Is it part of a project or research or another initiative? We often use metadata without even knowing it. With digital photographs, we don't have this problem a whole lot, but a lot of you still have photos at home with little or no information on the back to help you remember key things about the photo. A lot of us used to write stuff on the back of the photos, and you always have that box of photos you find, like, who are these? Who's this baby in this picture? But it helps remember the key things such as the date, a place, and who's in it. Maybe you remember, but will anyone else who happens to have possession of the photo know any of that information in the future. A photograph is an example of a type of data, and the information you include that describes the photograph is essentially a form of metadata. Nowadays with digital cameras, a lot of them digitally stamp a form of metadata about the film speed and the type of camera used and the lens and that kind of information. In this case, metadata provides legacy information that will help describe the photo for others who may come to possess this photo in the future. Without it, it's just another pretty picture. This happens to be an aurora borealis with a comet, but it doesn't answer questions such as the exposure, the type of film, who developed it, when, and paper. So digital pictures, you know, what information does the camera capture? And then how do I arrange that data in albums? We can expand on the organization of a photograph collection to understand the functions of metadata. To document the photos, you may want to include who is in the photograph, what is the occasion, where is it a special occasion? And to manage the photos, you may have them numbered to correspond with the negative or computer file. How will the photos be organized for discovery? Are they just randomly organized, or are they neatly organized in photo albums? And if somebody wanted a copy of the picture that you took, could you get it to them easily? And how do you go about doing that? Perhaps the best and most recognizable form of metadata is the card catalog system at the library. Although this is going away itself, everything's digital in the library these days. But each book in the library has information associated with it that tells certain things about the book, such as the title of the book and perhaps a brief description, who is the author, when is the book published and who published it, how many pages is in the book, and where can you find this book in the library, and what format is it in. Note that the card catalog entry does not speak to the quality of this book, such as I go and pull this book off the shelf and somebody had spilled coffee all over it, and I can't read half of it, or it's waterlogged, or somebody's dog ate the one page that I need for a reference. So that's one thing that card catalog does not speak to is the quality. This is a small piece of metadata for this picture here. At the NOAA Coastal Data Development Center, we write metadata in accordance with the standards set forth by the Federal Geographic Data Committee, the FGDC, and they have endorsed the ISO standards and are migrating to ISO. And we'll get into what is ISO in a minute. But this is a small portion of one such document. Having metadata in a standardized form allows easier access through a searchable interface. And this ability to be easily searched increases the value of the associated data and helps cut down on costs associated with data duplication. Look at the title, and remember, keep this in mind when we're talking about reading and writing metadata. You want to have really good titles so that you can see things. But this would be the data that you can access online, and this is the ISO metadata that describes this data, that answers all those who, what, where, when, why, and how questions. Now, metadata refers to background information on something. Metadata is just like the information that you would learn on the labels of a tuna can and cat food. On the labels, you can learn everything about the can's contents, the nutritional values of the food, the number of calories and fat grams, and whether it contains preservatives, the weight, the company that packed it, and its location, if there's something in it that you're allergic to. Then you'd use that information to make a decision about what you want to do with the contents of the can, whether you want to eat it yourself or feed it to your cat. So the labels on the cans contain metadata. Labels tell us what's inside, whether it's on a package or the label on a CD. How many times have you had a blank CD, and if you look at it in the light in a certain way, you can tell, okay, there's data on the CD, but what data is on the CD? So writing a label on the CD is very important as well. Imagine that you have these two cans, and you have them in the pantry, and the labels fall off, and you go to pull one out, and you even after you open it sometimes, you still can't determine is that ravioli or dog food. And it's scary. So a lot of times, you need to know more information. And also, the expiration date is very valuable information to know. So metadata is a component of data. It should never be viewed as a separate entity. Properly documented data provides vital information to interested parties. And there's a lot of, it's really hard to find graphics that refer to metadata, but this is a little cartoon that I like a lot that shows the collection specifics about this professor. The concept of metadata is familiar to most people who deal with spatial issues. For instance, a map legend is pure metadata. Like the label on the can, the legend contains information about the publisher of the map, the publication date, the type of map, the description of the map, the spatial references, that's important, the map scale and accuracy, among other things. Also, it tells you what symbols, what those mean. In the form of a paper map, metadata is readily apparent and is easily transferred between map producers and map users. There's a legend printed on the bottom of that map. But when maps are in digital form, the metadata is equally as important. But its development and maintenance often require a more conscious effort from data producers and the chain of subsequent users who may modify that data to suit their particular needs. Such as if you reproject it, then you need to update the metadata and add the processing information that this map has been reprojected, because that changes the scale and accuracy. How many of you have had to search for data and you find the data source, request the data, and when you get the data, it looks like this? You really don't know what columns are what. You can kind of infer from getting this, okay, it's in a text format, and it looks like velocity data. All right, I'm going to guess that this is a date and maybe a timestamp, but I don't know what this information is. I also don't know the units that any of this is in. So then I have to call back the person that I ordered this data, requested this data from, and figure out, okay, how is this data processed? What is this data that they sent me? What are each of these columns? What are the units? Who do I contact if I have more questions? What are the valid domains for this? Are there any outliers? Because this right here jumps out at me as not being consistent with the rest of them. So, I mean, why is that number so out of the range of a lot of the other ones? So where do I go for that information? If metadata accompanied this information, I would know that I'd have a date in UTC, I'd have a time, I'd have velocity east, velocity north, these are all in centimeters per second, I'd have a speed, I'd have a direction, and I'd have a water temperature in degrees Celsius. So if I didn't have metadata to tell me what each of those fields were, I would not know any of that information. And I would spend a lot of time trying to go back and forth with the data provider. And the data provider would spend a lot of extra time every time somebody had requests about their data, answering those questions. And if you had metadata that associated, that was a component of this data file that went with it, then that would drastically reduce the efforts on both parties' ends. All right, often metadata is described about the data, Metadata captures information about a data set or data product that describes certain characteristics of the data. It allows others to make certain determinations about its potential uses, but it does not reproduce the data. It describes the data. This information is better, but it still lacks some of the vital information that we need to use this data, such as what is season_ID1? What is that? What units is this in? How can I further define these elements? I get a little bit of information here, but I have 20 here for concentration. Okay, density species is found. Okay, so I get 20. What units is that in? Is that 20 different species? But also, what's the valid domain that constitutes high, medium, and low? and then why is 20 there instead of a high, medium, or low? So again, we need more information to use this data. And metadata would answer that. All right, so metadata describes the characteristics of data, the content, condition, and quality. And why would we care about the condition and quality of data? Can we use this data? And what about liability issues? Metadata should never be considered a separate entity. Metadata is an integral component of any data or data set, just like a label is an integral component on a can of cat food. Without metadata, no data set can be considered complete. Metadata is a critical component of a complete data set. Metadata is simply descriptive information applied to a digital geospatial file. Without accompanying metadata, the fitness for use of any given data set is unknown and its usefulness is significantly impaired. Metadata is created and maintained as an integrated part of the data creation process instead of something that might get done at the end of a project if time allows. Metadata should also be updated to reflect changes in the data. Mount St. Helens has changed drastically since May 18, 1980, and it's still changing to this day. Other things, the Cape Hatteras Lighthouse, it's drastically changed. If you go to its location that was previously marked, you'd be standing in water because this lighthouse was actually picked up and moved inland to avoid it being lost at sea. The names of things and the names of places also change. You know, spellings of things also change. And metadata should be updated to reflect this because the data has been updated. Also, organizational shifts and a lot of government agencies and state agencies get reorganized every so often. And so then you have to kind of create the trail of who owns this data now and who do I contact this and where is this data stored now. So you need to update that information. So now we're going to talk about the value of metadata. Why metadata? Why does an organization need to be able to track its data or share its work? What about the employee who's ready to retire? Do you know what he did or how he did it? What were his processing steps? What about the grad student who's leaving? Do you even know where their data is? And are you going to be able to contact them after they leave or after they graduate or after the person retires? Are they going to even pick up their phone? Properly documenting a data set is the key to preserving its usefulness through time. Proper documentation is often overlooked when people develop new databases for geographic information systems processing, and when essential information about data is missing, the value is severely reduced, leading to several key questions. Where did the data come from? Where were the data collected? How accurate are the data? What is the appropriate use of the data? Without clear and complete documentation, we have no easy resolution to these fundamental questions. Confusion created by uncertainty leads to a lack of confidence in the data, and the lack of confidence blemishes the outcome of any analysis in which it is used. If we all work together now, in the future, we shouldn't have to wonder about the accuracy, completeness, timeliness, or availability of geospatial data. Using data from 25 years ago or more is not uncommon. And data created in 1994, may be used in 2020. The long-term studies of climate, ecosystem health, animal populations, contaminants, geology, and other issues need old, if you will, data. They need older data sets. Remember that the metadata will be there long after the person who created that information has moved on. For data developers, metadata helps to avoid duplication, share reliable information, publicize efforts, and reduce workload. The benefits of metadata for you as a professional. Metadata helps professionals share reliable information. It supports the creation of a data inventory. Documenting data and its availability gives agencies a way to measure production. Metadata helps you easily distribute your geospatial data. Metadata that conform to standards are the basic product of, can be put into clearinghouses. Those are online distribution catalogs of metadata that have been proven to be an efficient way of distributing geospatial, digital geospatial data. The process of matching your data needs with the data availability is made easy by searching the metadata records based on certain key fields. For data developers, it sets the stage for reuse and upgrade of your data. Metadata helps you publicize and support the data that you and your organization have produced. It helps reduce your workload by reducing the need to answer questions about your data. It helps you get in touch with your own data. At times, some professionals don't understand their data configuration as well as they should. As one expert put it, we are enabled in our own ignorance by increasingly user-friendly GIS software. Metadata can serve as a check for this condition. Metadata may be considered insurance. Metadata ensures that potential data users can make an informed decision about whether data are appropriate for their intended use. It also ensures that the data holdings of an agency are well documented and that agencies are not vulnerable to losing all the knowledge about their data when key employees retire or accept other jobs. The benefits of metadata for organizations: maintaining solid, accurate metadata shows evidence of prudent data stewardship and protects the public's investment. Metadata protects your investment. It protects an organization's investment in spatial data. Estimates of the total cost of operating an effective GIS, 50% to 65% of that cost is creating, acquiring, modifying spatial data. You want to take reasonable steps to protect that investment for both you and your organization. Metadata helps limit liability. Effective use of metadata can help limit organizations' potential liability for misuse of data. It is a good place for an explicit liability disclaimer statement. A number of metadata attributes reflect information that tends to limit liabilities, such as access and use constraints, distribution liabilities, technical prerequisites, and completeness and logical consistency reports. For this to be effective, metadata must be distributed with data. Insurance, it protects as an organization's investment in its data because data may last for centuries, but people have imperfect memories. When people change jobs or retire, they often take their mental metadata with them, thus diminishing the longevity of their work and decreasing the value of the organization's investment in their work. Metadata helps organizations by allowing them to share data more readily and cooperate with other agencies. Management objectives can be met with metadata: accessibility and security. You can determine if it's available. If you can't get to your data, they are useless and worthless. Organized data and information are easier to access and maintain. To discover data, it should be documented. And is it secure? Is your data physically available, or is it tamper-proof? For data users, metadata facilitates understanding. It gives you, as a data user, a quick overview of the data so that you can make a reasonable judgment about whether the data you find fills your needs. It helps you easily focus on the key elements of the data and not get bogged down in unnecessary detail because it follows a standardized layout and has common terms and definitions. It allows you to more knowledgeably, be able to skim the records quickly and easily, and you can kind of focus on what you're looking for. Metadata helps you enable discovery both inside and outside of your organization. And because it's in a standard, it will enable data discovery and access through web-based resources. These resources can be as simple as a hypertext links that you can browse, web-accessible folders, HTML versions of the metadata, to queries that you can make through clearinghouse gateways. This enhanced discovery and access has value for internal use in your organization. Within a county government, for instance, the planning development department can, list descriptions of their spatial data for use by others within the county government, and then they can access the data through internet-based resources. You can do it external to your organization again so that you can share information back and forth at the state or federal level. They have regional and national spatial data infrastructure clearinghouse nodes, and we'll discuss that in a session later on. And again, all this data discovery is all accomplished through the use of clearinghouse or clearinghouses, an online searchable catalog of standardized metadata records. We'll talk more about data discovery in our session on March 5th. We'll talk about the NSDI, the National Spatial Data Infrastructure, GeoPlatform, data.gov, and geo.data.gov. Again, those are places that once you do this proper metadata, we'll post that to. All right, that's all the slides for today's session. If you have any questions that were not covered in the chat, you can email ncddcmetadata@noaa.gov. And again, if you have several people in one class, if you could email those to ncddcmetadata@noaa.gov as well. You know, that way we can get a list of participants in the session and keep track of that. Next week, we're going to be going over ISO 101, the ISO metadata, its content, and how it's organized. So that's going to be next week's session. And again, I thank everybody for coming. And again, if you have questions that did not get answered, please feel free to email us at ncddcmetadata@noaa.gov. Thank you.